Okay, shall we start? Finished copying the question?
Sir, wait 7 minutes.
Okay. This is CP of A and CP of G. Kindly note it down. Okay. CP to the suffix of A, C to the suffix P, and P to the suffix A. And this is gamma. So generally, okay, finish the copying the questions. Later on, we shall start. Okay. Okay, shall we start? Shall we start? Still, you are copying the questions. Shall we start? Because it takes good time. Okay. It's a lengthy problem. That is why. Okay. Yeah. Generally, what happens, in the normal Brayton cycle, whatever we have learned up till now, there would be a compressor, correct? There would be a combustion chamber. The heat is being added there, and there would be a turbine. Simple mechanism was there. Okay, so this was a compressor, this was a turbine, this was a combustion chamber. So from here, the air was compressed from 1 to 2, the heat was added from 2 to 3, and the expansion process was taking place from 3 to 4, and it was returning back by decreasing the heat rejection from 4 to 1. So this is what was happening generally, and this we used to represent in a form of TS diagram as a simple way like this. Okay, simple way like this. So 1, 2, 3, 4. Simple, it was going on. Now, if in case the efficiency of the compressor was given, and if in case the efficiency of turbine was given, so what we used to do? We used to deviate the part to meet at 2 dash, and we used to deviate this particular part to meet at 4 dash. So this was the change we have learned. And one more change what we have learned, suppose if in case there is a heat exchanger. So this is a normal thing. I would just write here, normal Brayton cycle. So this is a normal Brayton cycle. So what happens in case of regenerative Brayton cycle? Anyone? What happens in case of regenerative Brayton cycle?
5.
Oh shit, even this is also copied. Just a minute. So Xbox was paid the handwritten. Copy. Okay, what happens in case of a regenerative now? Now, if I talk about
5.
regenerative Brayton cycle, yes, 5 would be introduced, isn't it? I'll just grab all this stuff. Regenerative Brayton cycle. So what happens in case of a regenerative Brayton cycle? So this will not be left like this. to 1 directly. Rather, the outlet of the gas was there, no? Okay, there the regenerator will come into picture. Just a minute. So this is incoming gas, you know. So this incoming gas will exchange heat from an outgoing gas like this. So this is an outgoing gas. So these two incoming gas and outgoing gas would exchange heat in a heat exchanger. So this is known as the regenerator. So here the heat would be exchanged, and this particular state we called it as state 5, and we have marked the state 5 here. So this is what was happening. So previously, if it is an open gas turbine cycle, 1 would be here and 4 would be 1. So understood between the normal and the regenerative Brayton cycle, what was the difference? Everyone?
Yes, sir.
Clear, right? Now you see what happens. Now, if I say there is an intercooler, okay, I will go to the next page rather. New page. And shift all this a little bit more. Shift all this a little bit more. Okay, this gives a clear idea, man. That's why I'm doing all this. Okay, before directly jumping into the problem, you must know why we are solving this. Okay, now what happens in case of intercooling? Okay, CC. Now it is intercooling, gas turbine with intercooler, I will write. So Brayton cycle with intercooler. So now I am drawing a Brayton cycle with intercooler. So how does it look actually? So in an intercooler, if it is using, so what happens there? What happens? Anyone? So here, the compression action would take place in 2 different phases. For example, there would be 2 different compressors like this. One would be a HP compressor, okay, and another would be a LP compressor. So air first enters here at state 1. This is LP compressor. This is HP compressor. HP compressor andre ಏನು? What do you mean by HP compressor? High pressure compressor. Okay. So there will be a HP compressor and there will be a LP compressor. So first air enters through state 1. First it enters the LP compressor. Later the output, whatever you get, that is cooled by an intercooler. So here you will be having an intercooler. So this particular thing I would call it as an intercooler. Okay. So after cooling the air which is coming out of it, this think this is state 2. So numbers can be altered, man. However you want, you can change it. From intercooler it enters the high pressure compressor. So intercooler cooling action takes place from state 2 to 3. Okay. Now from 3 to 4, the high pressure compressor will compress the things. From 4 to 5, heat addition. 5 to 6, it is your expansion in the turbine. Now this is the process. Okay. Now have to draw this on a TS diagram. Now what happens in 1 to 2? The pressure gets increased isentropically. So this is from the process 1 to 2. Please do understand this. This is very, very important. Pressure gets increased from 1 to 2 isentropically. Okay. Then it is cooled back to a certain state. Say it is 3. To the state 3, it is cooled back using an intercooler. From again after 3, it is again compressed using a high pressure compressor up till the state 4. So it is again compressed up till the state 4 like this. So up till state 4 it is being compressed. You can observe here. Okay, it is compressed. From here, from state 4, heat addition process takes place up till state 5, heat addition process. Now, from state 5 to state 6, isentropic heat rejection would takes place, not heat rejection. Expansion would takes place from 5 to 6 in the turbine. Okay. I'll just write it here. Right? So, again, it will come back to its original position by rejecting heat. So, this is how it is there. And this is ideal in nature. Right? This is ideal in nature. Okay. This is with intercooler. Now, suppose if I give you the efficiency of LP compressor, if I give you the efficiency of the HP compressor, and if I give you the efficiency of turbine, what necessary changes I have to make in a TS diagram? Anyone?
2-.
Correct. So it would deviate this particular path, which is because the efficiency of LP compressor is given. So it will come 2- here. Next,
Dash.
because 3-, 4-. Why? Because the efficiency of the HP compressor is also given. So it would deviate a path and meet at 4- here.
6-.
Next, the efficiency of turbine is given. Therefore, it would deviate a path like this and it would become 6-. Clear, all of you, with these concepts? Clear? Any doubts? Harshir?
Sir, TS diagram of regenerative Brayton cycle. Sure.
Regenerative Brayton cycle. Okay?
So the
Clear?
final
Yes, sir.
one should be 4 to 1. It should be in between.
Where?
5.
4 to 1?
So that fifth intercooler is there, no? 5. It is between 2 and 3, no?
Intercooler. Intercooler, yes.
Sorry, this before one.
Regenerative.
Having a generator. So here,
Hmm.
okay, nothing.
Okay. Just there is an addition of state 5. Okay.
So
this
that
is
state 5 should be between 4 and 1, no?
No. Okay, see, this would assume that this would recollect like this something. So this is connected to here, something like this. Okay, assume it. Now, what happens, so the heat addition process, it is compensating the heat addition process. So literally, if I speak it, it should be 2 points, one at this and one at here. Because two different processes are you are touching, so 1 to 2 and 4 to 1. So these two processes are intersecting. So that's why it should be somewhere 2 different points. In order to make the things simpler, in order to make you understand, so what I have done is I have just made this. Okay, because based on this you can solve the problems. Otherwise, everything would be confusing for you.
Okay, sir.
Don't get too much involved in this. It is something else, Anish. It is not the thing what I am saying. I am just making the thing simpler, condensed, and so that it can be used for the solving the problems. Okay. Don't go by the concepts. Is that clear? Up till here it is clear. Very clear is draw. Everyone.
Yes, sir.
Okay. ಈಗ next ನೋಡಿ Brayton cycle. Brayton cycle with the reheater. Brayton cycle next in ಮಾಡ್ತಾ ಇದೀನಿ reheater ಹಾಕ್ತಾ ಇದೀನಿ. So reheater in the sense ಇಲ್ಲಿ ಟರ್ಬೈನ್ ಎರಡು ಟರ್ಬೈನ್ ಬರುತ್ತೆ. For example, compressor ಒಂದೇ ಇರುತ್ತೆ. So this is the compressor. Air gets in from state 1. Now air gets out as state 2. From this, the heat addition process takes place in combustion chamber. So from here, it comes out as state 3. So next, from here, what happens, there would be two turbines. One turbine is known as the high pressure turbine. High pressure turbine. So the outlet of this is again reheated using a reheater. So there would be a reheater which would be arranged like this. So from this reheater, again it would be connected to a low pressure turbine. Outlet would come like this. So this is low pressure turbine and this is reheater. So from state 3 to state 4, expansion takes place. From state 4 to state 5, again reheating takes place. Again from state 5 to state 6, another expansion takes place in another turbine. Okay, so let me draw a TS diagram for this particular arrangement. TS diagram. So there is only one compressor. So one compressor, big huge line from state 1 to state 2, isentropic compression. Next, heat addition from state 2 to state 3. Heat addition you have done from state 2 to state 3 like this. From there, using high pressure turbine, you are expanding the gas isentropically to a certain extent. Okay, up till state 4. Again, from there, what you are doing, you are increasing the heat to state 5. Again, you are increasing the heat to state 5. And then, after increasing the heat, you are again expanding isentropically to state 6 like this. State 6 like this. Again, 6 to 1, you can join back. Beautiful, isn't it? Are you able to understand these concepts, everyone? Yes? Understood?
Sir, how you are drawing this graph, sir?
How you are drawing graph in the sense? Just by understanding, Hashir.
Like it is going up and down, right?
Acha. Simple, Hashir. Let me tell you the logic. It's very simple. Now, what is the process that takes place in a compressor? Which type of process that takes place in the compressor? Which type? There are 5 processes, no? Out of which type of process takes place in a compressor? Hashir.
Yes, sir.
So which process takes place in the compressor? Which type of process? Yes, man. Anyone?
Compression.
Compression process, right? So out of all 5 processes, isobaric, isochoric, isothermal, adiabatic, and
Isobaric.
polytropic. So which type of process takes place in the compressor from state 1 to state 2? Which type of compression? Whether it is isobaric compression, isochoric compression, isothermal compression, adiabatic compression, or polytropic compression? Which compression it is?
Isobaric.
Oi, Anish.
Isochoric.
ಏನ್ರೋ ನೀವು ಹಿಂಗಿದ್ದೀರಾ?
Adiabatic.
ಇಷ್ಟು ಪ್ರಾಬ್ಲಮ್ಸ್ ಎಲ್ಲ ಸಾಲ್ವ್ ಮಾಡಿದ್ದೀರಾ? PVT conversion equations ಹಾಕಿದ್ದೀರಾ 1 to 2, P1 by P2 equal to V2 by V1 whole to the power of gamma, T1 by T2 whole to the power of gamma. ಯಾವ ಬೇಸಿಸ್ ಮೇಲೆ ಹಾಕಿದ್ದೀರಾ PVT conversion equation? So which process is from state 1 to state 2?
Adiabatic.
It's
Adiabatic.
adiabatic process. So if it is an adiabatic process, that is why you're using that P1 by P2 is equal to V2 by V1 whole to the power of gamma. When the gamma would come when it is an adiabatic process. Isn't it? That is why you're using that particular PVT conversion equation. Every time I write that sentence, 1 to 2 is applying PVT conversion equation for the process 1 to 2, which is adiabatic compression. Every time I write that sentence. That is why I have a legal license to use that particular formula, which is adiabatic process, just because it is adiabatic process. Getting it? So, if it is an adiabatic process, what is adiabatic process also called as? What is adiabatic process, which is also called as?
Isentropic.
It is called as isentropic process. If it is an isentropic process, which will be constant?
Entropy.
Entropy is constant. That is why, Hashir, I have drawn a straight line like this. Because it is adiabatic, because it is isentropic compression. Getting it?
Yes, sir.
Next one. See, all isentropics, all adiabatics will be a straight line in a TS diagram. If you can observe this. All adiabatics and all isentropics. This is 1 to 2 is adiabatic compression. 3 to 4 is adiabatic expansion. And same as 5 to 6 is also an adiabatic expansion over there. So that's why there are all straight lines in a PV diagram, TS diagram. Getting it?
Yes, sir.
Clear? Now, from whatever the heat addition process are there, those are curved in a PV diagram. For heat addition process in the sense, 2 to 3 is a heat addition in the combustion chamber. Am I right? 2 to 3 is a
Yes,
heat
sir.
addition in the combustion chamber. And
Yes, sir.
6 to 1 is a heat rejection in the atmosphere. 6 to 1 is a heat rejection in the atmosphere.
Yes,
Heat
sir.
addition. Now, 4 to 5 is again a reheating process, which is again a heat addition. Reheating, heat addition.
Yes, sir.
Yes, sir.
So that is why these are curves in a PV diagram. Getting it?
Yes, sir.
Yes, sir.
Now, Hashir, did you understand this?
Yes, sir.
Very good. Now you say me, now this is an ideal thing, ideal Brayton cycle with reheater. Now if I give you the efficiency, of a compressor, or if I give you the efficiency of the HP turbine, or if I give the efficiency of a LP turbine, so what necessary changes I should make in a PV diagram there?
2'.
So now it would not be at 2, it would deviate something and it would meet at 2 dash. Very good. Now, what about 3 to 4? Because efficiency of a HP turbine is given there.
4 dash.
So it would meet somewhere at 4 dash, like this. It would meet somewhere at 4 dash, just because efficiency of HP turbine is given. Now, because of efficiency of LP turbine is also given, what necessary changes I have to make?
6 dash.
It would be a 6 dash. This is 6 dash. Very good. Now, it would be fun if you draw all this in your notes for this particular thing. Let the class go waste. I don't bother. If I did not solve a single problem in this class, I don't bother. I want you to understand the concepts. That is my intention. Okay. Now I will just recirculate here. Very good. Next. Now, next you see, let's see how many of you could analyze this. Okay, now what I will try to draw is, I would try to draw a Brayton cycle. With reheater plus intercooler. Okay, if I have a reheater plus intercooler, so how many compressors would be there? How many compressors? Because it is an intercooler in between. How many compressors?
3.
Oh, 2. Intercooler. 2 compressors because there is a reheater. How many turbines? How many turbines?
2.
2. So 2 turbines, 2 compressors. Let us draw. So first, atmospheric air is sucked in.
Sir,
Yes. Hello.
how will come to know, sir, that two turbine and two compressors, sir?
Simple, Kana. You come back to this. Intercooler is there. Where the intercooler will come? Intercooler will come in between the compressors. Okay. Now, reheater is there. Where reheater would come? Reheater would come between the turbines. So, if in the question he specifies there is an intercooler, then automatically you should come to a conclusion that it has 2 different compressors with intercooler in between. Getting it?
Yes, sir.
Now, the question only held there. I have a reheater in my Brayton cycle. Then automatically you have to come to a conclusion that there are 2 different turbines with a reheater in between. Artha?
Yes, sir. Yes, sir.
Now, if I say there are both intercooler as well as a reheater, then what conclusion you have to come? You have to come to a conclusion that there are 2 compressors and there are 2 turbines. Understood, everyone?
Yes, sir.
Very good. Now let us try to draw this beautiful thing. Okay. Slowly, steadily, neatly. Okay. Now, first there would be a low pressure compressor which compresses the strings from state 1 to state 2. So after that, I have an intercooler. I have what? I have an intercooler in between. So this is your intercooler. So which cools the air to state 3. So after cooling, it is sent to a high pressure compressor. Then it is sent to a high pressure compressor. Okay. So it gets compressed here up till state 4. Now here you will be having a heat addition in the combustion chamber so that it changes its state to state 5. What happens next? Anyone?
Low
What
pressure.
happens next? Next is the high pressure turbine. Okay, high pressure turbine would come. So high pressure turbine I would draw in the reverse fashion. So this is high pressure turbine. So it would expand up till state 6. Okay, from state 6, what happens? Because I have a reheater, again you are heating up. So this is a reheater. Okay, this is a reheater. So from 6, you are again heating up to 7. You are reheating up to 7. From this, what are you doing? You are sending it to a low pressure turbine. So that it gets expand and exits out at 8. Beautiful, isn't it? Now, let me draw. Hashir, you have to help me out to draw a PV diagram for this. TS diagram. TS is more convenient to draw. Now, 1 to 2 is a low pressure compressor. So, adiabatic compression is happening, isentropic. So, what should I draw in a TS diagram? Hashir?
Straight line.
It's a straight line. Very good. So I am drawing a straight line from 1 to 2. Very good. From here, you are cooling. That means you are decreasing the temperature. Heat exchanging. So it is a curve. So it is a sloper line like this. I would just change the color. Okay. So you're decreasing the heat slope. So from here, it is state 3 up till state 3. Again, from here, what are you doing? You're compressing isentropically. So again, it is a straight line. Again, it is a straight line. So up till state 4. Very good. Okay. So from here, you are adding up heat in the combustion chamber. From state 4 to state 5, you are adding heat in the sense, again, it's a curve. So it's a curve up till state 5. It's a curve. From here, Hashir, low pressure, high pressure turbine, you are expanding isentropically. Then it's a,
Straight line.
again, it's a straight line like this. It's a straight line. So up till 6, you have expanded. From 6, again, you're heating it back. You are reheating the system. So to increase its temperature, that means you are playing with the heat, changing the heat. Then it is a curve which increases like this, right? It increases up till where? It increases up till 7. Now from 7, what are you doing? From 7, what are you doing? You are again isentropically expanding it. You are again isentropically expanding it to meet at 8. From 8, you are coming back to 1 by rejecting heat to a atmosphere like this. Beautiful, isn't it? Understood?
Yes, sir.
Yes, sir.
Sir.
So this is the essence of thermodynamics, man. See, how beautiful is it? How many of you are enjoying this session? Yes? Very good. Now. This is not over. This is still actual, man. This is still actual. This is still ideal. Now, if I give you the efficiency of low pressure compressor, if I give you efficiency of high pressure compressor, if I give you efficiency of high pressure turbine, and if I give you efficiency of low pressure turbine, what are the necessary changes I have to make in my TS diagram?
2 4 6 and 8.
Hey, wonderful, Aditya. Wonderful. Superb. So I have to make these necessary changes. That is, it would meet at 2 dash. Now here it would meet at 4 dash. Here it would meet at 6 dash. Here it would meet at something known as 8 dash. Okay. Beautiful, right? Understood? Now,
Yes,
I think there is a last combination that we can try. That is the Brayton cycle. Brayton cycle with regenerator plus reheater plus intercooler. This is the worst case scenario we can get in our examination, isn't it? All the three: regenerator, reheater, and intercooler. Let us try to draw this beautiful thing at last. Okay, the same thing would continue there. Copy. I would just it's a lot of things, so it takes time. Now if I paste it here, now what happens when I see already reheater and intercooler are used in this particular problem. Now what happens if I use a regenerator? So there would be an exchange of heat. 1 nimsha number 10. There would be an exchange of heat between the outgoing gas and incoming gas with an equipment which is known as the regenerator. Okay, and the state of this particular thing, what is the next particular state? So already 1 to 8 I have used. Shall I take it as 9?
Yes, sir.
So this is the state number 9. So where should I mark the state number 9 in the TS diagram?
Between 1 and 8.
Between?
1 and 8.
No, not between 1 and 8. You have to mark in between the heat addition process. 4 dash and 5. So here you have to mark your state number 9 if the regeneration process is being carried out. Understood?
yes, sir.
Yes, sir.
So this is module 2 for you. Okay. In this particular class, around 90% of your syllabus is being covered. I don't know why I have taken this division classes. I could have gone directly to solve this problem. Okay. I took this class particularly in the flow. I did not plan for this. Okay. It happened like that. So, but this covers every concept of your Brayton cycle class. Okay, every concept it has been covered there. You can have this in your notes also. If please try to draw all these figures, definitely you'll get a beautiful idea about this particular topic. And everything is covered, nothing is left. Okay, we have even imagined the infinite level of difficultiness in your question paper. We have clubbed all the regenerator, reheater, and intercooler, and this is the thing what we have obtained. And we will try to solve the problem which is this in the next class. Okay, hope you have enjoyed this class. Mark your attendance in the Google Sheet. We'll end the class by this, and we'll continue this particular problem in tomorrow's class. Okay, thank you. You can mark your attendance in the Google Sheet and you can leave.